Hello, molecular term symbols. In the previous three lectures, we have discussed about the atomic term symbols. Now we are going to discuss about the molecular term symbols. In molecular term symbols, it is based on the molecular orbital theory. So first we will discuss about the molecular orbital theory, then we will discuss about the how to determine the molecular term symbols. Molecular term symbol. Molecular term symbols specify molecular electronic energy levels. They usually consist of four parts: spin multiplicity, azimuthal angular momentum, total angular momentum, fourth is symmetry. All molecular term symbols discussed here are based on Russell-Sanders coupling. Molecular term symbols mark different electronic energy levels of a diatomic molecule. These symbols are similar to atomic term symbols since both follow the Russell-Sanders coupling scheme. The molecular term symbol employ symmetry levels from group theory. The possibility of an electronic transition can be deduced from molecular term symbols following selection rules. For multi-atomic molecules, symmetry levels play most of term symbols role. Now this is the molecular orbital theory. Because the molecular term symbol is totally based on the molecular orbital theory, is a set of concept and method that allows us to understand the nature of molecules with respect to symmetry and energy. The theory assumes that all atomic orbitals within a molecule combine and form molecular orbitals in which electrons are totally delocalized. A diatomic molecule or a diatomic is formed by two same or different atoms bound to their covalent bonds or ionic bonds. It is homonuclear if the two atoms are the same, or heteronuclear if different. In group theory, heteronuclear diatomic molecules have C infinite V symmetries and homonuclear one have D infinite H symmetries. This C infinite V and D infinite V are the points groups heteronuclear, or this is for the homonuclear. There are infinitely many representations in the both groups, among which the irreducible representations are symbolized using the notations this sigma, pi, delta, etc. This is in the group theory we will discuss the irreducible representations. Both kinds of groups bear a perpendicular mirror plane or sigma V. Sigma V is the plane passing through the internuclear axis or the axis of highest order, that is the principal axis. So plus sign and minus signs are used to categorize the symmetry with respect to sigma V. D infinite H symmetries indicate an inversion center in the molecule, yet C infinite V symmetries do not. For D sigma H, irreducible representations are further classified by parity using the G and U symbols. MO diagram describes the electronic interaction within a molecule using linear combinations of atomic orbitals. The orbitals are filled with electrons in an energetic order. the MO diagram for diatomic molecules. This MO diagram is used in B2, C2 and N2. This is the 2s electrons of one atom and 2s electrons of second atom. They combine to form the sigma 2s, sigma star 2s, and the 2p orbitals they combine for this pi x, pi y, pi x star, pi y star, and this sigma 2pz and sigma 2pz star. This is MO diagram for the oxygen and fluorine. In this case, the sequence of energy levels changed something. This is the diagram for diatomic molecules. In this diagram, the shapes of atomic orbitals and the shapes of molecular orbitals formed are shown. So this is, suppose this is 1s and 1s of the same phase. They will give the molecular orbital of this shape, and this is called the sigma 1s. Here the 1s and plus 1s, this is the different phase, then this gives the shape of this molecular orbitals, and this is called the sigma star 1s. This 2s and 2s is very much similar to 1s and 1s. Now 2px, this is the px orbital of one atom, this is the px orbital of second atom. If the phases are in the same direction, then this gives the molecular orbital of this shape. This is represented by sigma 2px. If this is px and px with having different phases together, then we will get the molecular orbital of this shape, that is called the sigma star 2px. Now 2py, if the 2py orbitals of one atom and this is the second atom, they combine to in the having same phase, this is the different phase, then the molecular orbital of this shape is obtained. And if they are in different phases, then the molecular orbital of this shape is obtained. This is the pi star 2py, this is the pi 2py, and similarly 2pz orbitals combine in this, they will give the molecular orbital of this shape. This is called the pi 2pz, and 2pz in this manner they will give the molecular orbital of this shape, that is pi star 2pz. These are the symbols represented by the molecular orbitals. So this is the sigma 1s orbital. This can be represented by sigma g1s also. This is linear combination of atomic orbitals, MO, and this can also represent by 1 sigma g, that is SCF, LCAO and MO. Similarly, sigma star 1s can be represented by sigma u 1s, 1 sigma u. Sigma 2s orbital is represented by sigma g2s, and this is 2 sigma g. Sigma star 2s will be represented by this method is sigma u2s and 2 sigma u. Similarly, these orbitals these molecular orbitals can be represented by in this manner and in this manner. How to determine molecular term symbol will be discussed in the next lectures. Thank you.